Hey guys, this is Stephanie. I want to introduce to you Steve Mary. He is with TVA. He's actually retired from TVA and couldn't stand it, so now he's back with them as a consultant. He's a lifelong engineer, and he has been involved with BEST since we started in 2011. So he's one of our faithful volunteers, and he's going to guide you guys through the engineering notebook and design process.
Thanks, Stephanie. Good afternoon, everyone. Like Stephanie said, we're going to go through the engineering notebook and design process. We want to take a look at the engineering notebook, the types of things that you need to include in the notebook, and at the end of the presentation, we'll go through some of the score sheets that will be used to evaluate the notebooks that you turn in. The first thing that we need to point out to you is that the notebook specifications are identified by BEST Robotics. You can get to those at the website here on the screen. Anything that we tell you doesn't count unless you find it on the BEST website. So you always need to go to the website to verify what should be in your notebooks, what the requirements are. Those are the rules and regulations that are going to be used if you go to Big BEST, and we want you to do as well as you can there, so we need to follow their rules. Okay, a few things that we use in evaluating the notebook. The first is the implementation of the design process, and we'll go into more detail on most of these as we go through the presentation. The second is a research paper. We want to know how you think the game is set up and why it's important to be able to develop this particular robot that you're about to design. We want to know what your brainstorming approaches are. How did you evaluate problems? How did you identify ways to move forward? Okay, we want to look at the analytic evaluation of your design alternatives. How big are your wheels? How fast will your robot run? There will be things that you will calculate, and we want to see those calculations in your notebook. We want to see your offensive and defensive evaluations, basically the gaming strategy. How can you best achieve points? Or in the defensive side of things, what could you do that would perhaps keep other robots from scoring higher than you? We always want safety to be a very important thing for you. We always want all the students to come to the competition in the fall with all of their fingers. So we want to make sure that you're following good safe practices in the work that you're doing as you design and build your robot. And then we want to make sure that everybody goes home safely after each meeting. We want to see your support documentation in the notebook as well. What types of things did you find on the internet that helped you with the design of your robot? It could be something as simple as some of the basic drawings that are shown that are out on the BEST website, and it could be something real detailed that would go into some special function that you built into your robot. We'll also rate the notebooks on their overall quality and completeness. The notebook should do a good job of identifying what you have done, how did you come up with the design for your robot, and we'll go into a few more details on a subsequent screen. Okay, first is the planning and preparation. With the preliminary knowledge you have of the problem to be solved, you're going to assemble a team to design and build a robot and try to make the robot that will perform the best, score the best on the field. You want to look for team members that bring a variety of skills to the team. You don't want only people that know how to cut wood to make wheels. You're going to need people that can do the programming. You're going to need people that can do the graphics on your robot, people that can help keep your engineering notebook. You need to voice opposing opinions when the need arises. You don't want to get in a habit that one person is making all of the decisions for the team. Everyone has an opinion, and everyone's opinion should be respected, and you should consider those things because you may make changes in your robot that will improve it. You need to be able to accept criticism as readily as well as provide it. You don't want to be the naysayer. You don't want to be the negative person on the team. But people need to be able to accept constructive criticism and maybe alter their opinion based on that criticism. You want your team members to participate equally as both a worker and a leader. Each of your team members is going to be good at something, and that something will be the thing that they can lead. But yet you also need people that will show up for your meetings, that will help do the build. Okay, we want to abide by the ground rules that your team establishes. That'll be one of the first things your team does, is determine what the ground rules will be so that when you do come together, you can be as productive as possible. Okay, each meeting is a part of the process of building the robot, and you should have a first step that confirms the following roles are assigned and that those that are assigned are ready and prepared to perform those tasks. It'd be nice to have someone that can do camera and or video recording so that you can document the process that you go through to design your robot and build your robot. Your meeting minutes need to be well documented. This is not for capturing every discussion, but it needs to capture all of the key decisions that are made as you progress with the build of your robot. If you design wheels, you need to document how you came up with that design, and then if you find it's necessary to change that design, you need to document that fact and keep up with all those in your engineering notebook, or at least in the minutes, so that you don't repeat mistakes or you don't go back and spend time repeating investigations to find an improvement for your robot. The meeting minutes should identify who participated. You want to know which team members were there, and then if questions arise, you can remind people, well, you were at the meeting and you saw it, or you may see that person wasn't at the meeting and find out that there was information that they needed that they did not get. The meeting minutes need to be reviewed and confirmed prior to ending the meeting. Sometimes you're going to find that there just isn't time at one meeting, so always set aside time at the next meeting at least to review your meeting minutes and let everyone weigh in on whether or not those meeting minutes are accurate. Okay, you should be making some ad hoc drawings, just kind of some rough sketches as you go along. You may not go to the trouble of doing CAD drawings for everything. The ad hoc drawings are going to be those things that you're just in the process of designing, so you're making sketches to build some ideas that you're later going to put in CAD. So those should be captured in your notebook. And then you should use an in-process notebook. What we mean by that is that your notebook should accurately document each decision that you make and the things that went into the decision that you were making. Okay, the engineering design process that we'd like to see you use, the very first thing is to identify the problem. You need to review the problem statement and refine that as required to achieve consensus and completeness of your team. Sometimes there may be multiple problems, and what you need to do is try to identify what is the most important problem to work on at that time and carry that one problem to completion before you try to tackle others. Okay, you want to develop specifications and requirements. The specs are going to be quantitative values that you're provided You're going to be given specific things about the robot. It has to fit in a certain size box. It has to weigh less than a certain amount. And then also there will be some that will just come along from the problem definition. There'll be some things that your robot has to do that you identified in the problem statement. So if one of the things you need to do is pick up a ball and put it in a tub, then here you would want to have a specification for that. How big a ball, how fast do you want to be able to move it, those sorts of things. Also, the requirements are going to be typically going to be textually based statements that tell you what you've got to accomplish, and in some cases what you need to avoid by working toward the solution. You also want to prioritize your specifications and requirements to identify any conflicts, and then also provide a focus for the design phase. By that we mean your specifications should be what drive that final design of your robot. It's very easy to find some additional things that it would be nice for the robot to do or cute for the robot to do, but those are going to distract you and may keep you from ultimately having your robot meet the specification that you developed. Okay, then you want to generate some possible designs. One good way to do that is through brainstorming activities. The brainstorming activities will give all of the members of your team an opportunity to put their ideas out there to be investigated. Sometimes you'll do that with breakout groups, and you always want to use it to generate the different designs that you can then evaluate to determine what's going to be the best design for the problem that you identified. You always want to break large problems into smaller sections or smaller problems and work on them one piece at a time. You don't want to try to eat a whole elephant. You want to eat him one bite at a time. So that's kind of what this is saying. And you need to have a very clear understanding of what your objective is before you can do that. So back to the specification. Okay, you want to repeat this process as many times as is needed. So you may do your first brainstorming session on how is our robot going to move around. Are we going to do it with wheels? Are we going to do it with tracks? How are we going to drive our robot? Then you would come back and start to look at the tasks that the game requires, and you would take each task and run it through this same process. So if it needs to pick up a ball, that's the first thing you would do. If it needs to pick up a bottle, that would be the next task maybe that you would try to run through these brainstorming activities. And then as a group, you're going to evaluate each design and determine if another iteration is needed, or have you reached consensus that this is the design that you want to move forward with. Okay, the next step would be to model and simulate your latest design. You can use whatever tools are available to you to model and visualize how that design will perform. You might want to make a model. You might be able to do that with one of the CAD programs where you can animate the robot. You want to look for interferences and weak points. If you need to, the robot has to fit in a certain size box when you start. So the first thing you would want to do is look to see, is your robot too big to fit in the box? You want to evaluate the design for structural durability as well as functionality. Is the robot going to be able to do that task and do it multiple times without breaking? You want to compare the design that you come up with to the criteria that you developed in step 2. So is the robot going to perform and do the task that you identified that it needs to do? And then you want to repeat the consensus check. You want the whole team to weigh in to determine if the design needs to be repeated or refined. Now, we've used consensus a couple of times, and I'd like to point out consensus doesn't mean that all team members agree that it is the best design. Consensus simply means that the team agrees that that is the best approach at this time, and there may be some opinions that there are some things that could be better. And the thing to do is reach consensus, build the robot, run it through its tests, and then you can determine whether or not the design needs to be repeated. Then we're going to build a prototype. You don't want to assume that you can go directly from the design to the final product. You'll build at least one prototype. You may do a good enough job in your brainstorming that everything works just fine, but the odds are pretty good that you're going to build the first prototype and you're going to find something that it could do better if you modified some piece of the robot. You always want to stay true to the design when you're building your prototype. If you start to introduce design enhancements on the fly, you're going to lose track of what your final outcome should be. And then when you finally complete the prototype, you may not be able to figure out either why it's not doing something you wanted it to, or why it is doing something that you didn't want it to. So, and these design enhancements are, if design enhancements are needed, you would go back to step 3 and make sure that they don't degrade or interfere with other parts of the design that are currently working. The next step is to test and evaluate. You want to test the prototype against the prioritized criteria. If the objective is to pick up a ball and put it in a tub, you want to do that with the robot and verify that it will indeed pick it up from where you need to pick it up and place it where you need to place it. If this is the first prototype and it's suitable by consensus, then you might want to refine the details and the design data and build either a competition model or a second prototype that are using the same guidelines as those above. You'll repeat this test several times to make sure that all team members can support the final design and that they're familiar with the aspects of the operation. You always want to also keep track of your schedule, because you're going to be on a pretty tight time frame from the time we tell you what the game is until you have to have the robot on the field. Okay, first, identifying the problem. We want to define the problem that we're trying to solve. If we just build a robot to do something, how do we know that it's going to do what the game is, or what we need it to do? The problem will probably consist of most of the following: some kind of technical challenge that you've got to achieve. There'll be criteria in how the appearance of the technical solution is evaluated, also criteria in how the operation of the solution is evaluated. There'll be a carbon-based life form resource constraints. So, you're going to, there are pieces of your robot that will break, we promise you. So you just need to be sure in your design that it's something that you can fix between rounds. We also want to look at the physical and quantitative material resource constraints. You're going to be given a certain amount of material, and that's what your robot has to be built from, with the exception of a few parts that are allowed, but we don't provide those. So you need to make sure that you're only using the materials that you're given. And then you've always got the time constraint problem. I'm sure all of you have seen times that you just wish there was another 20 minutes, and you don't have that. So, your team meetings are going to fly by fast, and I promise you the time between the reveal of the game and the competition is going to fly by too. Okay, there are a couple of brainstorming approaches that you can use. We've used mind mapping and a product improvement checklist. And you just need to look for a way that you can best identify ideas with your team and document those ideas. Okay, we're also going to use analytical math skills to compare and contrast different possible designs. Some of the things that we may evaluate would be the speed of the robot, the durability of the robot, and the strategy of the game. So all of those are going to come into play as we develop the design of the robot. Okay, now the offensive and defensive evaluation basically is the gaming strategy. What is the objective of the game? How do we score points? And how can we score the most points? Okay, safety. The very first thing is training. We want your team to develop a training plan for all of the team members and then conduct that training with all the team members. There will be safety equipment. Game day, you will be required to wear hard hats, safety glasses, and high visibility vests. Those may not be needed at your team meetings, the vests, but we highly recommend that you always wear eye protection. Anytime you're dealing with if you're cutting anything, if you're sawing something, you can get things in your eye, and the safety glasses will prevent that. Like I said before, we want everybody to leave every team meeting safely. Okay, the support documentation for the engineering notebook. First one here is the CAD or other drawings. You can download drawings from the BEST website and use those in your engineering notebook. You can also use any CAD drawings that you prepare and any hand drawings that you prepare. Sketches would be just fine, so long as they document either parts or your complete robot. Photographs are great supporting documentation. As you're going through your design and build, someone can easily snap some pictures, and you can include those in your engineering notebook. Your team minutes. It's important that you document each and every change that you make in the robot, the things that went into, the decisions that went into making that change, and then also the results of that change. And you need to have those in your team minutes so that you can then, if you go back and review your minutes, you may find that you need to make a change in your robot, but you could go back and look to see, have we already considered that change? Did we rule it out for some reason? Or you may pick up your robot and say, why is this like this? And in that case, you can go back to your minutes and find out, why did you make that? Why did you put that design change in the robot? And what did you expect it to do? And is it doing what you expected? And then that leans toward test results. As you're building your robot and you're testing your robot, you need to document those results so that you can either avoid making the same mistake a second time or identify enhancements that you want to keep. Okay, we're going to look at your notebooks for overall quality and completeness. We're going to look to see how well is your notebook organized. We need to be able to find all of this information in your notebook, so therefore we need a table of contents, and then you need to put things where the table of contents says that it is. We want to look at the appearance of your notebook. We'd like them to look professional, and that doesn't mean that they have to be done in Word or in PowerPoint. There are people that have neat penmanship, and handwritten notebooks are just fine as long as they're neat and readable. We want to make sure that you're adhering to the specifications. Do you have the information in the notebook that is required? Is that information complete and concise? Can we find it in the notebook? And then the next thing would be the quality of content. We're going to take a look to see how well did you document your design process? How well did you document your brainstorming methods that were used? We want to make sure that the quality is high, and you'll be able to see on the score sheets how these are going to be rated. Some typical pitfalls in the notebook that you might want to try to avoid. One is direction versus participation. You know, one person telling all the other team members what to go do doesn't necessarily constitute participation. Participation would mean that all your team members had a part and helped with the design and the build of the robot. Another one is not capturing details and therefore repeating mistakes. That's why it's important to keep the minutes of your meetings and keep them in a notebook or together in one place so that you can quickly go back and take a look to see, have we already tried that, or did we have a reason that this was made this way? And it'll help you repeat mistakes. It'll save you time. Another one is ad hoc design on the fly. Simply, we're building the robot, we move a servo, or we change a wheel size or something like that, and you don't actually consider that. You don't sit down and consider the design effects of making that change in the robot. So you could end up with a robot that won't be able to cross barriers. It's sitting too low to the ground, so it can't cross barriers, or perhaps it has to reach and pick up a ball someplace, but all of a sudden the arm is too short to reach that high. It's going to be important to manage your time. There's never going to be enough of it, or at least that's what it's going to feel like. So always in your designs, plan for some contingencies. If you think a particular task is going to take 15 or 20 minutes, you might want to allow 30 or 45. It'd be better to finish early than get to the end of your time and not be finished and have to figure out how to pick up that time later. Another pitfall is not sharing responsibility. There probably will be someone on your team that is willing to step up and be the team leader, but if they don't share responsibility, you're not going to have as many new ideas. You're not going to have as many ways that you can attack the game, and you're kind of going to be limited by just the decisions that one person's going to make. And then another pitfall is not reviewing the completed work. You make a change in your robot, you try it out, it doesn't work exactly the way you wanted to, but it kind of worked, and walk away and go on to the next change. So you haven't really completed the evaluation of that change that you made, and that could lead you to make mistakes later. Okay, if we're going to go through a few things that are, well, actually we're going to go through all of the criteria that are included in the Project Engineering Notebook score sheet. The score sheet will be posted with the presentation, so it'll be posted as an attachment. So you'll be able to see the actual score sheet that the judges are going to use. Okay, the first thing is the research paper, and these are in no particular order. They're just in the order that they're on the score sheet. We want to make sure that you understand the correlation between the game and the science or technology that's being used. The idea of the game is to build a robot to tackle a problem that somebody out there in the real world has. We want to make sure that you can see how the game and that real world condition are related. The research paper needs to include any related information of the game theme, such as the history, famous inventors, or major milestones associated with it. So we want you to do a little bit of research on the problem and tell us, you know, why is this an important problem to solve? What were some of the ways that inventors went after this problem in the past, and how did those help you in the design of your robot? We want to see creativity in linking the game theme to the appropriate science content, and we'll score that in the score sheet. We also here you go. Your English teachers will like this. We want to make sure that you're using proper grammar and composition. This is supposed to be a professional engineering notebook, and so we need to spell words correctly and we need to use proper grammar. As you can tell listening to me, I don't use proper grammar all the time either, but when I write, I try to go back and hit the old Microsoft Word spell checker and let it help me. Whoops. Okay, the next scoring category is the design process. We want to see how well you've implemented that design process that we went through. We want to see evidence that the engineering process was effectively used, so that's scored pretty highly. We want to see your brainstorming approaches. How well organized and productive was your brainstorming? What technique did you use? Did that technique really result in consensus, or were some decisions made just because somebody wanted that decision made that way? And we want to see that, and we're going to score that in your engineering notebook. The next category is the analytical evaluation of the design alternatives. We want to see how you analyzed, and especially where calculations can be done, we want to see those calculations that helped you decide on how you were going to implement the design alternatives. How did you determine that one design was better than another? Would it allow your robot to move faster? Would it allow your robot to move through areas that it would have trouble moving through with a different design? So we want to see how you analyzed the robot that you finally designed. Okay, and then we want to see an offensive and defensive evaluation. We need to see an analysis of the gaming strategies and the design elements that you use to achieve those. So for example, there'll be a task that scores a certain number of points. Tell us why you went after that particular strategy. How is that going to result in the most points for your team at the end of the competition? Okay, and then we're going to look at your software design and simulation, and this may change this year. This was new to the engineering notebook last year, and it may be modified a bit this year. But we want to see some evidence that you've done some custom software design. Have you done some programming to make your robot perform differently? We want to see evidence that you've used Simulink or some similar product to verify the robot programming. And we also want to see good software design practices implemented. The next category is safety. We can't emphasize that one enough. We want to see evidence that your safety training occurred, that you did document the training that you were going to present, and we want to see that you're using safe work practices. One kind of pitfall related to this one is if you've conducted safety training and it says that anytime you're using power tools you will wear safety glasses, and then you've got 6 or 7 pictures in your notebook that show people cutting plywood without safety glasses, we're not going to score you real high on this category. We want to instill in the students the fact that safety is very important and that they are in control of their own safety. So we want to make sure that you're following the training that you developed and that you're using it as you perform the tasks. Okay, then we want to see some support document. We're going to score your support documentation. There should be drawings in your engineering notebook. They can be CAD, they can be hand drawings. We want to see photographs, your team organization. It could be an organization chart that you build in PowerPoint. It could just be a handwritten list of your team and what their functions were. We want to see your meeting minutes and test results that are supporting that engineering document. Okay, we're also going to look at the overall quality and completeness of your notebook, the organization and appearance. You know, does it look like a professional paper? Remember, you're trying to sell that robot to me. So you're going to have to show me why that is the best robot for me to buy. We want to see adherence to the specifications. You know, the notebook needs to be in a standard binder, in business font, no smaller than 12 point, and all of these are specified on the best website. Then we also will look at the quality of the content. Are descriptions well written? Are the photographs clearly labeled? Just having a page with 4 or 5 photographs, we won't know who the folks in the picture are nor what they're doing. So we need labels that tell us those things. We also don't want to see just a lot of extra material. We're not going to grade the notebooks based on the number of pages. So, you know, having 50 pages is not better than having 25. So we're going to look to make sure that the information that is there is necessary and that there's not just a lot of fluff in the information. Okay? And that completes our review of the engineering notebook. Okay, I mentioned that the best website has a lot of information that you can use. What I'd like to do now is actually show you where that information is and give you some resources that you can access on the website that will help you improve your engineering notebook. Okay, first we'll go to the best site. We're going to go to Participants and File Manager. Notice there is a 2016 game file, but it is locked. You don't have access yet. So you have to wait until we release that for you. There are archives that show some of the games prior to 2015. And what we're going to look at right now are the public resources, because these are the things that everyone has access to. Okay, here in the public resources, there are several different categories, and I'm not going to go through all of these. What I'm going to do right now is drill in and show you some example engineering notebooks that are available on the site. But be aware that all of these different categories are available to you. And we're going to go for where I'm headed. We're going to go to the Team Resources. And in Team Resources, again, you've got several choices of information that you have access to that you can use as you prepare your robot this year. And then I'm going to go to Examples. And here are several engineering notebooks that you can take a look at. We will open one just so you can see it. And I did not choose one that I think is the best. I chose one at random. So, you know, these are just some ideas and things that you could use to help as you develop your engineering notebook. And we'll shrink it to a size that fits the screen better. And so here is this team's engineering notebook. Notice there's a title page. They then have the table of contents so that we can find things within their notebook. And then they go into all of the information that we covered on the notebook. Here's a pretty good, this probably came from PowerPoint, but there's a good organization chart, good example of an organization chart. And then they went into their strategies, and how they developed and what they developed. Okay. Now we will also have, whoops, that was supposed to work. There we go. We will also have posted on our North Alabama or Northwest Alabama BEST website, we will have the scoring sheets that we use for the various awards, and then also some of these are scoring sheets that are used to help us evaluate the engineering notebooks. So you will be able to see these on the BEST website, or actually on our local hub website, so that you have an idea how your notebooks are going to be evaluated. And it wouldn't be a bad thing for you to take these scoring sheets and score your own notebook. That'll give you an idea. It may help you identify some things that you need to change. You can identify strengths in your presentation or in your notebook, and maybe weaknesses. If you've got strengths, you don't want to take those out because they're giving you high points. And if you have some weaknesses, those are areas that you might want to consider making some improvements in the notebook. Anything else we want to show? I think that should.
Thanks, everybody. If you have any questions, wait, Steve.
Paused.
Oh, you did. No.
We don't want to stop, but I paused, didn't I? Yeah.
If you have any questions, you can email me, and we can try to do like everybody's questions and response sheet back out to everybody at some point, either in the summer or during the season. Thanks.